I do, but if I don't listen to it.
All right. This is the final section in chapter 2 that we're going to take a look at. We'll start reviewing tomorrow, and then test will be early next week. What? We're going to take a look at a few proofs today. I'm being serious when I say the proofs that we did are the hardest proofs that we will see all year. Right?
I think you're lying.
Well, I'm a man, so you can trust me. Alright, so the first part of this section, okay, is really similar to things that we've already done. Okay, we've talked about these different relationships already. We've talked about corresponding angles, alternate exterior angles, consecutive interior, and alternate interior angles. Okay, so this section is about kind of going the other direction. Right? So in section 2.7, what we said were, if lines are parallel, then corresponding angles are congruent. Then alternate exterior angles are congruent. Then consecutive interior angles are supplementary, and alternate interior angles are congruent. Today, we're just going to flip that statement. Okay, we're going to say, if these things are true, then the lines are parallel. Okay, it's called a converse, when you flip an if and a then. Okay, so we said before, if the lines are parallel, then these things are true. Now we're saying, if these things are true, then the lines are parallel. Okay, and we actually have another one that we're going to add in there today. This fifth bullet point down here says, if two lines are perpendicular to the same line, then those lines are parallel. Okay, and hopefully that makes sense intuitively, right? We have a picture of that. We're saying if we've got two different lines that are perpendicular to the same line, then those two lines would have to be parallel. Right? Should make pretty good sense. So, the way that these questions are worded, right, are, well, for this first one, okay, we're told that the measure of angle 1 and the measure of angle 2 have to be equal. So, we remember, marking that information on a diagram means drawing the same number of arcs in those angles. So, if I know these two angles have the same measure, first of all, what would be the relationship between those two angles? Wow, there are 3 different answers.
Here you go.
There's the 4th. I've heard all 4 possibilities.
Consecutive. That one.
So we can at least cover up this bottom half, right? Because now these two angles are in the same position, just on the other line, right? This one's in the bottom left, this one's in the bottom left. That's corresponding, okay? So if two angles are in the same position, just on the other line, that's corresponding. So now, if I know these angles are corresponding and they're the same, which two lines could I say are parallel? R and S, right? Or S and R. So again, we have no information about this bottom line here. So what we can say is R is parallel to S. Okay, and those two basically parallel lines is our symbol for parallel lines, right? This says R is parallel to S. And then what we're going to say, okay, our reason, it says state the postulate or theorem that justifies your answer. Our postulate or theorem is the corresponding angles converse. Okay? So when we're proving two lines parallel, we're going to state basically the relationship between the angles that we have. We're just going to tack on the word converse because we're flipping all of the statements that we had before. Okay, so these two lines are parallel by the corresponding angles converse. Okay, we okay with that? Okay, so now the other problems on the front of our paper here are basically types of problems that we already did in section 2.7. The wording is just slightly different, right? So in this example, it says, find the measure of angle ABC, right? So my ultimate goal is to find the actual measure of this angle so that M and N are parallel. Okay, so before we said, given that these two lines are parallel, solve for X or find the measure of an angle. Now it's just saying, find the measure of the angle so that these two lines are parallel. It's the same type of problem, right? So if these two lines are parallel, what would be the relationship between these two angles here? Alternate interior, right? They're on the inside of the parallel lines, on opposite sides of the transversal. So what does that mean then? Are they equal, or do they add to 180? They're equal to each other, right? And I mean, hopefully we can use a little bit of common sense for that too. I mean, these two angles, our only two options are they're equal or they add to 180, right? These are pretty small acute angles. There's no way those are going to add to 180. So even if you forget, our alternate interior, congruent, or add to 180, use a picture, right? Use a little bit of common sense. So our setup would just be 3x plus 10 equals 6x minus 20. Solve for x. So get the x's onto the right side. Add the 20 over to the left. And we should end up with x equals 10. Is that my answer?
It always could be wrong.
We gotta find the thing. Yeah. Right? Degree, right? So I gotta plug this back in. We want the measure of this angle.
Yeah.
Actually, it doesn't matter which one I plug it into, right? Because they're the same. So we'll say our final answer, measure of angle ABC, it's going to be 40, right? 6 times 10 minus 20 is 40. Yay. Okay. You okay with that? All right. So we're running a little bit short on time. So since these problems on the front are the same types of problems that we've already done, let's flip over to the back here and take a look at a couple of proofs. So, in this first example, our goal is to prove that AB and DC are parallel. Okay? So we're given two different sets of congruent angles, right? I'm told angles 1 and 2 are congruent, but I'm also told 1 and 3 are congruent. Okay? So what would be the reason for my first line here? Given, right? We just are restating those givens. Well, now, if 1 is congruent to 2 and 1 is congruent to 3, why can I claim that 2 is congruent to 3?
Alternating interior.
So I think that might be the most confusing part. Okay, so some of you did give the correct answer, but I want to address what Clayton said here. He said, well, they're alternate interior, so they have to be equal. Right? That's only true if we already know the lines are parallel. We don't know that already. That's what we're trying to prove. So I can't say that these are the same because they're alternate interior if I don't know the lines are parallel yet. So a few of you said we could use either transitive or substitution here. Those would be our correct possibilities, because in this first statement, we're saying two different angles are congruent to the same thing. If two different angles are congruent to the same thing, then we can say they're congruent to each other. Or we can say I'm going to substitute angle 2 in place of angle 1 because I know they're congruent to each other. So either substitution or transitive would work here. So now, if I know that angles 2 and 3 are congruent, why can I claim that those two lines are parallel? So this is the new idea now. Okay. Right. Okay, so now we're going to use the idea to say, well, if these two angles, these alternate interior angles are congruent, then the lines have to be parallel. So we're just going to say, since these are congruent, the lines are parallel by the alternate interior angles converse. Okay, so once I'm able to prove that we have one of these relationships, right? I mean, we could eventually show corresponding or alternate exterior, alternate interior, right? Once I'm able to show that those two angles are congruent, then I can claim that lines are parallel, right? Real quick, let's try the other one on here. Got 2 minutes. So on this one, I'm given two different things, right? I'm given angles 1 and 5 are congruent, and I'm given angles 15 and 5 are congruent. So let's see. Line 1 is given, and then they tell me line 5 is the other given, so I'll go ahead and put that in. And it's always a good idea to make sure you have your givens in the right spot. Well, then they say, if 5 is congruent to 15, 13 has to be congruent to 15. They're vertical, right? So I know those are congruent because they are vertical angles. Then, well, so I can only use that if I know the lines are parallel. We don't know that yet. So here we could either say transitive or substitution because I've shown both 5 and 13 are congruent to 15. So either transitive or substitution. So now they claim R is parallel to S. So now it'll be corresponding angles, right? If 5 and 13 are congruent, then the lines are parallel by the corresponding angles converse. So now they say if corresponding angles are congruent, then lines are parallel. So my goal is to prove that L and M are parallel, right? So they already said 1 and 5 have to be congruent. So my final line is just going to be L is parallel to M because that's what I want to prove. Questions?